I'm Ann-Christine from UNSD, and following up with what Alex has just told us from the methodology point of view, we had the idea to provide code that makes it as easy as possible for other countries to follow the UK example. So what I'm going to show today is a Python class that we wrote that is called AIS Trade Indicators, which makes it easy to get two of the indicators that Alex presented, but which also has some limitations in the flexibility how to use it. So first I would like to show what we want to see in the end. This is just one example for the time and port indicator, and what we see is an example of selected Indonesian ports, and it shows the time and port in seconds. It's one of the indicators Alex just showed us. And this is basically what we want to have in the end. So we want to see the time in seconds per port, or when we also have an area which is not in the port because we have like this rectangle of the country. And we also see the period. So we have it for the months from May to November in 2019. So this is what we want to see in the end. And now the question is, what kind of inputs do we need? So what do you need to define for your country to get these indicators? And for the input information that you need to define using this AIS trade indicator class is, first of all, an app name, which can be any name that you can come up with. It's just to distinguish between the running processes on the cluster. The second decision you have to make is to choose the data set, which is a feature in this kind of sense. And in our case, for example, it's EE2 for the exact Earth data. Soon, I'm pretty sure that we only will have this possibility, but at the moment, there's still two data sets you could choose, the exact Earth and the Ofcom data. Then you need to give your username, which is just defined by your by the access you got. You need to specify the time frame, so what is the start date you're interested in and the end date. For in our case that I just showed, it was the 1st of May to the end of November. Then you have to define this rectangle that Alex showed us. Like you have to define which area in general are you interested in. In this example, it would be Indonesia, but it depends on which area you want to look at. Then you have to come up with kind of a definition of moving ships. Alex explained to us that you want to find out the ships that are actually moving and not staying in the harbor for the whole time. So you need to come up with the difference of latitude and longitude and the sum of longitude and latitude that defines moving in your case. This can differ from the UK case, but can also be the same. It depends a bit on how far are the ports from each other, or what you want to define as the ship is moving in your application. And then, of course, we need to define the ports. So what we need to for this class that we wrote is the port name, just to have it in the end result. And then, of course, the position by latitude and longitude. And then we use an expansion factor to define the port area. So it's just an expansion around this coordinate that you give for the port. This is a really rough a definition for the port area. It would be more precise if you could have a cluster algorithm, or maybe if you had a polygon around the port. But this is just to make it easier for a first try. And then what we get out of what we get as an end result from this class is the time and port indicator and the port traffic, the two of the three indicators that Alex just showed us. And this is just the same table we have seen at the beginning. So this is in theory, so this is what we need and what we get from the class, but we now also want to have a look at how it looks like in the Jupyter Notebook. So I'm going to show the code above later on, but I first want to show what you have to do if you're interested in getting these two indicators for your country. So in the first step, we define this AIS class. And what we do for this is we give this add name, which could be any name. I just say Indonesia trade because I'm now interested in the selected Indonesian port. Then I say set the feature. In my case, I use the exact AIS data. That's why I set it to EE2. And my username, which is A. Kreutzmann. This you know from your credentials that you get. Then we have to set some, it's more so that the whole thing can run on the cluster. We need, and that we can use the GeoMesa functions. We need to configure the GeoMesa setup and also need to start a Spark session. This is quite technical, and because this could maybe also scare people off when you see the code that is behind this, we just made it easier, but you still have to set these configurations and to start these sessions. But it just, without any arguments, you just copy paste this code and then it should run. We will have a look at this later, but also there's the first training where we explain a bit more what it means to set these configurations and to start this session. In the second chunk, in the fourth part of this code, we have to filter the data. What do we mean by filter? We want to decrease the number of cases that we are interested in by setting the start date, which is here May 2019, and the end date. I set it to the 1st of December, but then it means we look at the end of November. And also I define the area in general that I'm interested in by an upper limit and a lower limit of the latitude and the longitude. So this is what you have to define for the application you're interested in. And then we're coming to the part where we define the moving ships. I told you this can differ. Like this is the definition of UK, which say that the absolute difference between the maximal and minimal latitude is larger than 0.2, same for the longitude. And then they also define something for the two differences, the sum of the two differences. I just used this as it was defined in UK. I think it's this 0.2 meant around 50 kilometers, or Alex? Do you know?
Yes, depends on which part of the Earth actually.
Yeah, exactly. It differs a bit on where in the Earth you are. Yeah, but so this can differ across the applications. But yeah, this needs to be defined so that you have a definition for what is a moving ship. And then we come to the definition of the port. So we define port coordinates. And what we do here is we give a name just to distinguish between the different ports. Then we define the port latitude and longitude, so just the position of the port. And with the expansion factor, what we say is like we define the rectangle, like the box around the port coordinates. And the function also returns what this means in coordinates, and then you can maybe check visually if this makes sense in your case or not, if you need to change the expansion or if this is okay. And then we come to the actual calculation of the indicators. So we start with the time difference that I've shown you, and we use the function time diff next port to define the difference between the time. We define an absolute months just to distinguish exactly between the different months. And then we can calculate the time and port when we define these two things. And what we get back from this function is this table. This second function here just helps to recalculate from this absolute definition of months, which is not so easy to read, to the period as it's shown here. So this is not necessary, but it makes it easier to read the table. To get the results here, you need to use the time and port function. And this part of the code just exports this result to my account. So I have this also as a CSV file. And we don't see the result for the port traffic, but it basically works the same. We have a function, it's called port traffic, And instead of the seconds, you would see the numbers of ships as a result for each port, or number of unique MMSI, to be correct. And we also export this data set. So this is what you can do to start to get indicators for your application, for your country. And you don't have to define too many things. You just have to define the arguments that are actually specific for your application. Coming back to the code, it's a bit more that is behind these functions. But I don't want to go through everything, like what I said. Okay, we have this GeoMesa configuration, we start a Spark session, but we have a training that was more specifically focusing on all these single steps, and that's the other training that we advertised also with the invitation to the AIS Data Week. So I just want to slowly show you that this is what is behind these functions. And if you're interested in all the single steps, I want to refer to the other training. But of course, you also need this code to run the functions. Yeah. So maybe now I want to open the floor for questions. No questions?
So this is actually a super simple question. I guess maybe if we go back to the other training, we would know. But is there a difference between EE and EE2? Like we've been using just EE in our queries.
Oh, sorry, my mic was moved. It is defined for like exact Earth, the exact Earth data. It's defined EE2. It's not defined as EE, so it doesn't work with EE. It won't find any data with EE.
Okay. What's the difference between the two? We've been using EE. That's why I was just wondering.
Oh, really?
EE2. Yeah, I thought I had read somewhere that they said, oh, the EE2, because we joined recently, and I went back through the messages, and I thought they said at one point EE was magically made into pointing to the same place as EE2. But I just want to make sure that's true or not.
Okay, then maybe I need some support from Alex, because
EE2
I only worked with EE2. I didn't even know that they also have dataset for EE. Alex, do you know more about this?
I think there is only one data set from exact Earth available, so probably there are different mappings to the same thing. Probably we can check with them. But I'm not aware of two different data sets. There is OrbCom, which is different. Yeah.
Yeah, that's different.
Okay, but Alex, do you know if they access the same data set with EE?
I think they're the same data set, yes. Just
Okay,
Okay.
thanks.
but, yeah, we can check.
Thank you for all this, by the way.
Do we have other questions? If there are no other questions.
So, okay, and Christine, maybe you can share also where we can find this code.
Yeah, so you can find the code on the AIS handbook that I showed yesterday. It is in the chapter for the how to use AIS data in the UniGlobal platform, and there you will find the old code, which goes step by step, where you see every step that is hidden in the AIS class. But you can also download the AIS class and use the code that I've just shown. The differences are that the step-by-step code is a bit more flexible, so you can change more things without breaking anything. And the class is a bit more limited in the options, but it's easier to use.
Okay, thank you.